All right, so we're going to go ahead and get started with the, I think this is the final FE review of the year, isn't it? Is there any one more? Okay. Okay, all right. So let me go ahead and get the slideshow started, and then let me see. Okay, now it's putting the slideshow on the other screen. Let me see if I can. Hold on, give me 1 second. I'm trying to get the slideshow to play on the current screen. Monitor, primary monitor. There we go. That's better. Okay, so we're going to cover two topics tonight. Let me get the lights adjusted in the room. We're going to cover probability and statistics, and then we're going to cover computational tools. So probability and statistics, it's going to be some pretty basic stuff we're covering tonight. We're not going to do anything that's of any substantial difficulty. And as I'll mention here in a second, we're going to make really heavy use of our calculator because a lot of the statistics stuff, especially things like standard deviations and weighted means and things like that, a lot of this stuff the calculator will do for you. Things like linear regression and whatnot, it can take a lot of time to do by hand, and if you understand the tools of your calculator and whatnot, will go quite quickly. All right, and here's this as well. What's that? Yeah, but hey, I think this topic will knock out quite quickly. Now, one of the things about this topic, specifically the statistics stuff, more than I think any other on the exam, if you are good and understand the modes and operating procedures of your calculator, this stuff goes by quick. And I mean really quick. Unfortunately, I don't have the little applet installed on this computer, so I can't pull up the calculator. But I'll do my best to try and write out, what buttons to hit and whatnot to get you through a lot of this. Now, we're going to be using the Casio FX115. So if you don't use this this calculator or one like it, to be honest, a lot of the modes and stuff that we go through in here probably isn't going to help you very much. But regardless, if you use a different calculator, if it's a TI or something, many of these functions are present in those calculators as well. You just need to learn it. So if you're using a different calculator, just adjust accordingly. So we're going to discuss two topics tonight. The first is going to be probability and statistics, so let's get into it. I've got, I think, 7 questions and whatnot. So this should be a pretty straightforward topic. Okay, so to start, question 1 is, what is most nearly the sample standard deviation for the data set shown? So we have 4, 6, 9, and 9. Now, just to do my due diligence and to ensure that I'm not just showing you how to hit buttons on a calculator, we are going to go through the algorithm just so that we're fairly clear on how that works. But when we do it on the calculator, we're going to find how quick it is. If you're good with it, you probably could have already had the answer in the whole time I've been standing up here talking. Now, I printed off a series of handouts for the FE, and one of them was the components of the manual that are relevant to prob stats. Now, if you look in that section, particularly on the left column on the first page, right around down here, you'll find the formula for the sample standard deviation, and it is as follows. So that formula, do I not have edit on this? Should be able to write on this. Let me get my technical difficulties worked out, and then we can get this thing started. All right. View, current slide. Now, why is it not letting me write? All right, well, fine. I will write on my notebook. All right. So we're going to go through the algorithm just to sure that this works. So problem 1, all right, we have the data set 4, 6, 9, 9. Now from the reference manual, page 39, so I'll put page 39 of NCES. That way everybody's following where I'm getting this. Oh, sorry, nope, page 37. Page 37. We get that the sample standard deviation is as follows. So it's the square root of 1 over n minus 1, where n is the number of terms in your data set, times the sum of your variances squared, which I guess actually no, that wouldn't be the right term. It's this variance is essentially your sample standard deviation squared, so I don't want to use that. Okay, now in my opinion, I think the easiest way to go about this, if you want to go through and actually do the process, is to set up a little table. Okay, so we have 4, 6, 9, and 9. Okay, now over here off to the side, how do you compute the average of this data set? I know that might seem like a pretty basic question, but we're in review mode, so maybe I'll sort of do this whole thing. So first off, how many terms do we have? Well, we have 4 terms, right? The sum of those terms is 4 plus 6 plus 9 plus 9, so 4 plus 6 is 10, 18, so that's 28. So therefore, the average is 28 over 4, which is 7, right? Make sense? All right. So my first column, I have my individual measurements. I'm then going to determine the difference from the mean. So if you want, you can say the deviation from the mean, the individual deviations. So the first one, we have 4 minus 7, so that's going to be minus 3. 6 minus 7 minus 1. And then we've got 9 minus 7, which is 2. And then this is 2. Now, it doesn't really matter what direction you do this subtraction because you're going to square it. Okay, so negative 3 squared, that's 9. Negative 1 squared, that's 1, 4, and 4. Summing those up, 9 plus 1 is 10. That makes 18. So to compute the standard deviation, it's just the square root of 18 over 4 minus 1. There's my formula. This entire sum on the right. This is 18. That is 4 minus 1. So 18 over 4 minus 1 is essentially, that's the square root of 6, which comes out to about 2.4. So the answer is B. Okay, now that's if you want to go through and do the algorithm. Okay, now that's not a lot of work, but that was 4 data points. Imagine if we had 8 data points. It's not a lot more, but it does start to add up. And if you've got something like linear regression that you've got to deal with, yeah, that starts to add up. Okay, so since you're given the calculator on the exam, use it. Okay, so I've got my trusty. Actually, let me clear that out and get back into regular computational mode. I got my trusty Casio FX115 EX Plus. So I go to mode. Now, originally the calculator's in mode 1 because that's just basic computations. We're going to go into mode 3 for statistics. And we're only dealing with one variable, just a single set of numbers, so one variable. And you should see a little table pops up that has a bunch of rows under a column, in this case, X, single variable. So we're going to enter in 4, 6, 9, and 9. So we just do 4, equals 6 equals 9 equals 9 equals. When you're done, you hit the AC button, okay? And it should go back to your main screen, and it should have the little 0 there at the bottom. So the calculator has stored that data set. Now we want to do something with it. If you hit Shift and then hit the number 1, if you look above 1, you'll see Statistics and Distribution. So Statistics and Distribution. We have a number of options. What I'm going to do is hit Variable 4, and I can get N for the number of terms, X bar, which is the mean, sigma sub x, which is the population standard deviation, S sub x, the sample standard deviation. Just hit 4, and Sx should pop up on your cursor, hit equals, and there you go. Simple stuff, right? You're going to love it when you see the linear regression, because if you went through and did the math, it's not hard, but it saves you a lot of time. Any questions? We're going to use the calculator functions on the next one as well. Okay, so let me go to this one. All right, so problem 2 is indicating what is most nearly the mean of the following data set. So here, this is a little different because we've got, let's say, the value 2,480, it was observed 23 times. The value 2,440 was observed 35 times, and what have you. So we're essentially just calculating an average, but you have to go through and you know, you think, well, what's the formula for an average? Well, you'd have to add up 2,480 23 times, or essentially multiply it by 23. Instead, I'm going to use the calculator. So we're going to go to mode. We're going to go back to computational mode to clear out everything that we did in statistics. Now, what I'm going to do for this problem is I'm going to go to Shift and then hit Setup. Okay? So right next to mode. Now you'll notice a number of options, you know, degrees, radians, fixed, all that stuff. If I go down, it brings up even more options. Okay? And if you look, what does option 4 state? Stat. So if I hit that, this tells me whether or not I can enter data points with a given frequency. So for this problem, I'm going to turn that on. Okay? Now, I'm now going to go to mode, go to 3, and then to one variable again, because I'm still in one variable statistics. And now the table should look a little different, because you should have an X column and then a frequency column. Everybody have that? All right. Now what I'm going to do is I'm going to start off and enter in all these values on the left. So I'll say 2480 and hit equals. 2440 and hit equals. And notice how it's automatically assuming that they are at a frequency of 1. We're going to go in and change that here in a second. 2400 equals. 2360 equals. 2320 equals. Okay, so I should have 5 rows of data. Now what I'm going to do is I'm going to use the arrow cursors to go up to frequency on that first one, and then enter in the frequency. So 23, enter. 35, enter. 40, enter. Or equals, I guess I should say. 33 equals, 21 equals. Then hit AC again. That'll put you back in your home screen. Then you go to Shift and 1, to where it's the same thing. We're going to look at that statistical distribution. I want to go back to variables, but in this case, what's the problem asking for? I'm asking for the mean. I need X bar. So 2, asking for X bar, hit equals. What does it say? 2401.5789, what have you. And what's the answer? C. Not too bad, right? Simple stuff. Any questions? Now, before we do this problem 3, I want to observe the algorithm, okay? Because I really want you all to understand sort of how you would do this if you didn't understand your calculator's functions. So I want you to turn to page 40 within your handbook. So actually, let me pull this up on the screen so that the folks watching the video can see this as well. All right, so here's the video, or obviously here's the video. We're sitting here watching it. All right. Let's see if it's going to zoom in. There we go. Okay, so what we're looking at right here is on page 40 of your hard copy printout, and we're looking at least squares, okay? So specifically, we're looking at this set right here. So let's just be clear and make sure we understand what's going on with the problem. With this problem, we were given a series of points, and any engineer has done this. You plot a series of points, and then you say, all right, let's try and fit a line through that. So this is just basic linear regression. Now, Excel or programs like that will do this very nicely for you, but if you want to do this by hand, it's actually somewhat tedious, okay? Because you need the sum of all the x terms, the sum of all the y terms, the sum of all the x squared terms, the sum of all the x times y's. You need a lot of individual sums. It just gets real repetitive real quick. Instead, you could just do this with your calculator like that. So let me show you how this works. So I'm going to go to mode and go to 1 to get back into computation and clear out everything with my statistics register. And then we're going to go to mode 3, and then I don't want to hit anything yet. I want to take a look at this, okay? Now, we've been doing mode 1 within statistics because that's one variable, okay? Now, mode 2, see where it says a plus b times x? Okay, it is doing linear regression. Now, I want you to think about this. What's the slope of that line according to this regression? B, so keep that in mind, okay? So we'll go to mode 3, 2. Now, you should have a table pop up. Now, if you've still got your frequency column, no big deal. We're just going to leave all the frequencies equal to 1 since all the points just show up once. And here's our points. So we have 1, 6, 2, 7, 3, 11, 5, 13. So I'm going to go through and enter the x values first. So 1, 2, 3, and 5. So 1 equals, 2 equals, 3 equals, 5 equals. Now, if you notice what it did is it automatically populated all the frequencies with 1, but it also populated all the y coordinates with 0 because it's just assuming everything's on the same line or on the, at the same y coordinate. But we need to go in and change that. So I use my cursors, go up to the first point. What do I have? 6, 7, 11, 13. So 6, 7, 11, 13. Bam. So and then I say, all right, now that I've got all my data in appropriately, hit AC. And then I go to Shift 1 for statistics distribution. Now, I've got type, data, sum, variable, and then I also have regression. Okay? I need regression. So I hit 5, and then what am I going to ask it for? B. Why am I asking it for B? Because the problem is asking for what is most nearly the slope of that line. So hit 2 for B, hit equals, and it tells me the slope of that line is about 1.857, etc. So, C. Now, if you want, we can do the algorithm by hand if you'd like, but it's long. Getting to that point, so essentially what we would have to do is this, and you all can look at this if you want, but we would have to pull all of our x, or sum all our x values, our y values, x squared, y squared, x times y, and then we would have the following regression coefficients that we'd have to compute, SXY and SSX, the slope is the division of those two. So it's a pretty involved calc. It's not hard, it's just long. Okay? Does anybody have any questions about this? All right, next one. Now we're getting into the world of probability. Okay, if it'll click, there we go. 4 fair dice are thrown. The probability of rolling at least 1/6 is most nearly what? Okay, now a problem like this, really the easiest way of going about it with these probability, or I'll say this, anytime you see this at least 1/6 or at least one result, the easiest way to go about that, in my opinion, is this. Okay, so let me ask you a question. If I throw a fair dice, just a single dice, what is the probability of rolling a 6? 1/6. Okay, if that is the case, what is the probability of not rolling a 6? 5/6. Make sense? Now, if you go back to your probability and statistics course, if you have 2 events that are independent of one another, and you're asking for the probability of a given outcome on both of those events, you essentially multiply. So the probability of, think about it like this, the probability of rolling a 6 once is 1 out of 6. The probability of rolling a 6 twice would be 1 out of 36. Make sense? Right? Okay with that? Now, I propose that the probability of not rolling a 6 once is 5/6. The probability of I got crowded. Let me scrunch this over here. The probability of no 6s on 4 rolls would be 5/6 times 5/6 times 5/6 times 5/6, or 5 to the 4th over 6 to the 4th. You okay with that? Everybody good? Okay. Now, that is what that number is the probability of not getting any 6s at all. Okay? Now, what I'm asking for is the probability of that not happening. And I propose that the probability then of at least 1/6 is 1 minus that. So what does that come out to be? 0.517. What's that?
How would you work it from the other end instead of like doing like a back calculation of the probabilities of it occurring instead of all occurring?
Well, I guess the easiest way of looking at it is to break the problem down into a little bit of a simpler fashion. So let's say we have a coin, a fair coin. Okay? So the probability of, here, let me put this up here in a different color. So the probability of heads would be 1/2, right? The probability of tails would be 1/2. Okay, so far so good? All right, so let's say let me see if I can come up with an accurate, well, let's just do it like this. Okay, if I flip the coin twice, there's 4 potential outcomes, right? Heads, 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 tails, tails, heads, tails, tails. Sound good? Okay. Now, with this logic, what's the probability that if I flip 2 coins, I get at least 1 heads? 3/4, because there's 3 instances of that occurring, and there's 4 total events. Everybody okay with that? Now, what I propose is by working backwards is by saying this, okay? What's the probability that I get no heads at all? That would be this one, 1/4, and then just saying 1 off of that. Does that make sense? Because I think this is the easiest way to explain what you're asking about without sitting here and just drawing every single instance for a dice. Because if I did 4 dices, I mean, what is that, 6 to the 4th, 36 squared? That's a lot. But does that make sense? Does that kind of answer your question a little bit? Okay. All right. Everybody good? This next one I think is going to make your life, or if you're if you like the formulas, the next one will work out pretty nicely. Everybody good? Okay. All right. Now, the next one says a bag contains 100 chips that are numbered from 1 to 100. So each chip has its own unique number. Now, 1 chip is drawn from the bag. What's the probability that the number on the chip selected will be odd or greater than 80? Okay. Now, this isn't that bad if you think about it. Now, what I am referring to is the law of total probability down here. Okay. So if you look, this is just a general law of probability, and the law of total probability says that the probability that either A or B occurs is equal to the probability of A plus the probability of B minus the probability that they both occur. Okay? Sound good? Now, let's sort of simplify this up a little bit. So let's say that A is, now we've got 2 events here. So what's the probability that the number on the chip is odd or greater than 80? Okay, so let's start off with A being an odd chip. Now, what's the probability of A occurring? Think about this. 50-50, so 1/2, right? If I draw a chip, it's going to have a 50% probability of being odd. Now, event B is a chip greater than 80. Now, how many chips in that bag, if the chips are numbered 1 to 100, how many chips in that bag are greater than 80? 20. So 20 chips out of a possible 100, 1/5. So I propose that the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. All right. Does that make sense? Now, how do you calculate this out? Pretty simple, okay? 1/2 plus 1/5 minus 1/2 times 1/5. And we'll talk about that times here in a second because this is a great example for that. All right? So first off, let's just calculate that out and see what it comes out to be. Three fifths, or 0.6. Now, everybody okay with that? Now, I just sort of magically said the probability of A and B is 1/2 times 1/5. Okay? Now this is a great example to explain why that works. Okay? Let's start off with the smaller event, the chips greater than 80. So there's 100 chips in that bag. How many chips are greater than 80? And you said 20. Of those 20, how many of them are odd? 10, half of them. So 10 out of 100, or 1/10 of the chips in that bag, meet the requirements of both those events. So in other words, half of that set of 1/5. So that's where the multiplication comes into play. Does that make sense?
Now, can we generalize this to say that P of A and B is always P of A times B?
Assuming there's no dependencies. Assuming there's no dependencies. But let's also be clear, this is not a probability and statistics exam. It's the FE. You see what I mean? So you're not going to get asked anything that's ridiculous. Does that make sense? Okay. That's a good question, but really a lot of this stuff is pretty basic. Yes, sir?
Back in previous reviews, we done problems that are like more complicated than what we do on the exam, but these seem like they might very well could be there.
Yes, yes. Let me say this. So a couple things about that. I'll be honest, probably a lot of that is coming from my own personal experience when I took the exam. And I know that's going to be a little different than yours. When I took the exam, we had a morning session and an afternoon. And the morning session, we had more questions, but more basic ones. So our chemistry, our circuits, our thermo, our math, our statics, dynamics were really basic questions. The afternoon, the soils, the structures, the whatever, we had fewer questions and they were much longer. So that's probably colored a little bit by my own personal experience, that when I did structures and steel and concrete, I had longer questions. Could I have covered the same topics by doing 15 short questions versus 6 long questions? Probably, but that's just sort of how I framed the review sessions, just because that's what I experienced. So I'm sure I could have taken those problems and broken them up a little bit and created 3 or 4 different questions out of them. So did that?
Yeah, so what I'm saying is like
These are pretty representative, I'd say. These are pretty representative. And I'll be honest, those structures questions, they are, but they were real, involved.
Yeah, they were just advanced like one section of that problem. So the entire
Yeah, that's a fair way of putting it. That's a very fair way of putting it.
And I guess
I'm already racist, but go ahead.
going back to where we worked with the frequency for the first time, just in order to save time, could we have assumed that, well, this is the one that's occurring the most, so the average must be around that number?
That's a reasonable estimate. But it also depends on your other values. Like if I tacked another couple zeros onto this one, I wouldn't, yeah. That's a good question.
Because that example was pretty close.
You're right. They were all fairly reasonable answers, and you're reasonably close values, and you could say, well, since the 2400 occurs the most frequently, that it's probably going to be, that one. One other observation to make, and we didn't talk about this, what was the mode of that data set? Remember what mode is? It's the most occurring. So everyone has the highest frequency. So. All right, sound good? Now this one is a little bit more on the heavy probability side. You are going to need your review manual for this, although I actually didn't heavily review this, but I think your Casio will actually do normal distributions. So now while you all are reviewing this, I'm going to turn to page 46 of the reference manual, and I'm going to go through this problem real quick. So the final tests or final scores on a test in a given class are normally distributed with a mean of 72 and a standard deviation of 10. So what is most nearly the probability that a student's score will be between 65 and 78? Okay, so let's sort of put a couple things up here up top. So we have a mean of 72, and we have a standard deviation of 10. Okay. So do you all remember when you actually, you know what? Let me do this on this sheet here because I'm going to need some more room. So 4. So mean of 72, standard deviation of 10. So what's that? Problem 6. You're like, it better be problem 6. I'm not going to stay here any longer than we need to be. All right. So here's my mean and standard deviation. And if you recall, what those define is what my bell curve looks like. That's about the best bell curve you're going to get out of me. So that was a joke. Not a very funny one. All right. So remember, your bell curve is defined by the peak being the mean, and then your standard deviation basically defines your spread, how spread out your curve is. Okay. Now, what we're trying to do is figure out the probability that the score is between 65 and 78. So if the mean is 72, what we're really trying to figure out is, 65 is somewhere about right there, 78 is somewhere about, I don't know, right there, and we're trying to determine that area, right? Please tell me you did stuff like this when you took probability and statistics. Yeah. Okay. All right. So something that should be somewhat familiar is a z-score. So I'm going to compute a z-score for 65 and a z-score for 78. Now the z-score is your observation, so 65, minus your mean over your standard deviation. In other words, trying to figure out how many standard deviations away you are, I guess is one way of looking at it. So 65 minus 72 over 10 is minus 7 over 10, or 0.7. Sound good? Now, this one's going to be 78 minus our mean over standard deviation, so 78 minus 72 over 10, which is 6 over 10, which is 0.6. I forgot a negative right there. Did that have what? Oh, sorry about that. All right, everybody good? Okay, all right. Now, before we do anything with these, I want to go to the reference manual to make sure everybody's clear on what they're provided. So I'm on page, I think it's 46. If you look at the bottom, page 46. And this is your unit normal distribution, okay? And obviously we're looking at the area sections, okay? So if you notice, we've got f of x is the area of the curve from, all the way from negative infinity to, some value of x away. So, it starts, I guess if we wanted to mark this out, it's starting right here with an x of 0 and then moving out. So, your first observation is 1/2, okay? Now, what I propose that we're going to do is this, so that you all have that in front of you. I propose that we're going to handle this problem as follows. We're going to say that this area is this, where that's 78, minus this, where that is 65. Okay, does that make sense? Everybody okay with that? All right. Now, so I propose that we're going to get this area from the capital F of x column, and we're going to get this area from the R of x column. All right. Does that make sense? Well, the R of X column is doing the tail.
R of X is the area to the right there. Or we just assume either tail.
Well, that's a good question. That's a good question. So I propose that if I have, oh, that's a horrible one, but that's about the best you're going to get. I propose that this area right here, if that's a z of 0, that this area and this area are the same. They're just flipped. Do you see what I mean? Okay. So help me out with this. Let's see. Let's start off with the top one. Okay, let's start off with the top one. So areas. So at a z-score of 0.6, what's f of x equal? So we're looking at this one right here. So what's that area come out to be? Keep in mind, this right here, say, okay, 7257? There we go. All right, and for everybody pulling up the video, we're looking at this column right here, and we're looking at essentially a z-score of 0.6. So at this z-score, we're talking about that data point right there. Now, as for the R column, essentially what I'm looking for is a z-score of 0.7, right? Just on the other end. Does that make sense? So what's that area going to be? What, 2420? Is everybody okay with that? So if you want, for your notes, you can say, yeah, I'm just flipping it over. That's what, yeah. So I'll say 0.7, symmetric. R of X, 0.2420. So therefore, our probability is just that minus that. Yeah, part of this is actually just learning the manual, you know what I mean? And if you're not given that, you're like, oh, well, I can't use the negative, so what do I got to do? I got to, interpret the table appropriately. So that comes out to be 4837 or B, right? Yeah, you would probably the middle was where z-score was 0, and you'd have negatives and positives, and it would be just one big table. Honestly, I think that would be a little easier to discern. But since this is what you're given, you kind of have to, interpret it appropriately. I'm not the biggest fan of it, but they don't listen to me, alas. Okay. Now, this one, there's a couple ways of going about this. There's an easy way and a hard way. Let me say this. There's an easy way and then there's a long way. Okay? So 4 fair coins are tossed at once. What's the probability of obtaining 3 heads and 1 tails? Okay? Now, one way of doing it is to do this. And say, and then just go on and then literally say, okay, 3 heads and 1 tails. Okay, so that one works. And then just saying the total number of observances divided by every one and just going through it. That's one way of doing it. That's a long way. Will it work? Yes, it will work. Okay. Okay. So let's be clear that that method does work. Okay. Another way is to go back to your distributions. Okay? If you remember in probability and statistics, when you have a data set, one of the goals of that science is to try and determine a data set, or try and determine a distribution that predicts that data set. And one of the most fundamental ones is a binomial distribution. Now, normal is trying to represent, real life things, like scores on tests or average daily traffic or whatever. But a binomial distribution works really well when you're dealing with data sets that are either successes or failures. So a coin flip is a very common instance of a success or a failure. It's either heads or it's tails. Make sense? Now, if you go to page 39 of your handout, your FE reference manual handout. First off, there are a host of distributions listed in your handout: binomial distribution, normal distribution, chi-squared, student's t-distribution, all that stuff. There's a host of them. They're all over the place. Okay, we're looking at the binomial distribution: successes versus failures. Okay, now what I'm going to do is this. Okay, so we're looking at the very top. So let me be diligent and pull it up on the video. Oh, let me erase my little marks here. All right. So we're looking right here. Okay. P of x is the probability that x successes will occur in n trials. If P is the probability of success and Q is the probability of failure. Okay? So there's our formula. N factorial over x factorial times n minus x factorial, P to the x, Q to the n minus x. I know it looks pretty nasty, but this is actually a pretty straightforward process if you think about what's going on. Okay? So I'm going to do this. So we're on problem 7. Okay, so binomial theorem. Or binomial distribution. Although there is some connectivity between the theorem and the distribution. Okay, now for the binomial distribution, you have to identify an event that is a success and an event that is a failure. Okay, so what I'm going to do is just pretty much arbitrarily say that successes are heads and failures are tails. Okay? Now, help me out going through the manual. What are P and Q? What's P? Little p. Okay, P is the probability of success. Now this is a fair coin. So what's the probability of success, which is the probability of heads? 1/2. What is Q? The probability which is also 1/2. Make sense? Okay. Now what's N? Now how many trials are there in this problem? There you go. Now X is what? The number of successes? No, I'm talking about right here. Look at this. So, yeah. So how many successes are we looking for in this problem? 3. There you go. Make sense? So X is the number of successes, which is 3. Okay? So therefore, the probability is n factorial over x factorial times n minus x factorial p to the x q to the n minus x. Does anybody remember what factorial is? Like, how would I compute 3 factorial? 3 times 2 times 1. Okay. So, what do we have? We've got 4 factorial over 3 factorial times 1 factorial, right? Times a half raised to 3 times a half raised to 1. Now keep in mind, this would work if we considered tails a success. And instead, we would not be looking for 3 successes, we would be looking for 1. It would still work. I can do better than that. Essentially, yeah. So, what do we have? 4 factorial. So 4 times 3 is 12 times 2, 24 times 0.5 raised to the 3 times 0.5 over 3 times 2 times 1 is 6. 1 factorial is 6. So this ends up being 4 times 0.5 raised to the 4. If you want to carry that out, you're more than welcome to. And it comes out to be 1/4. Any questions? All right, now, good news and bad news for what comes next. Good news is that you can take those little formula sheets that come from the manual and toss them away because you aren't going to need them for what comes next. Bad news is that I don't know that there really are any formulas for what comes next. What comes next is you got to have a little bit of common sense and a little bit of attention to detail for these computational tools. Now, there are really 2 types of questions that you're going to get asked on the FE in relation to computations. And usually they're pretty short. These really are pretty short problems. I don't want to say that they're trying to trick you, but in some instances they're trying. Let me see if I can state this appropriately. They're not trying to trick you, but they are trying to ensure that you're paying attention to detail. Okay? So the first type of question is basically just some programming. Okay? So here's a programming question. So we have a structured program that contains the lines of code that are shown in that box. Okay? And the question is, what is the value of y after the segment is executed? Okay? Now, the thing with structured programming on this exam is follow it line by line. Okay? Make sense? So let's follow this line by line. Okay. Let's do line 1. Line 1 says that y equals 4. Simple. Make sense? Line 2 says no change to y. Actually, let me do this. Let me do, if that's any better. That better? For y? 4. All right. Line 2 says that no change happens to y, but we now have a new variable b. Sound good? What does line 3 say? We take y is 3 times whatever b is minus 6. So what is 3 times b minus 6 equal? 6. B remains unchanged. Line 4. Is line 4 true? That if statement. If y is greater than b, is that true? Y is greater than b. So if that is true, y then becomes b minus 2. What is b minus 2? 4. Wait. No, that's 2. What's that? See what I mean? It's all about attention to detail. All right, 5. Is line 5 true? Okay. So what does y become? Y becomes y plus 2. So y is 2, y then becomes 4 again, right? Six. Does y equal b? So then y becomes b plus 2, y becomes 6. That's the whole point, is to, it's not hard. It really isn't, but understanding what's up,
Yeah, because really, when you think of it, I think of it in terms of MATLAB. Establish y and b, and that's never going to change. And then you're only going to decide.
You realize, though, in MATLAB, you can change variables within statements and loops. You can't. No, you can. That is true. All right. Does that make sense? Okay. The next one, I'm not going to lie to you. The next one's a little harder, okay? And it takes a little bit of thought. Okay. So, a structured program contains the lines of code shown in that box, okay? For which input values of x will be such that the output value equals the input. So, if I input 7 and I get out 7, you know what I mean? What values does that occur for? So let's follow through the program. So I input some value of x. Then the program makes a determination. If x is less than 5, it computes some value of t. Otherwise, it computes another value of t. Does that make sense? All right, it ends the if statement and then it prints out whatever t is. Sound good? All right, so let's take each of these one at a time. Now, what I'm trying to do is figure out what values of x will generate the same value of t. So let's look at this first one. I want to set these equal to one another. So setting them equal to one another, first off, I've got t equals x times x slash 16 minus x. Why don't I just say t equals x squared over 16 minus x? Sound good? Now, I want this t to come out to be x. So now I just need to solve this equation. All right? So what do I have? X times 16 minus x equals x squared, right? With me on that? So 16x minus x squared equals x squared. So what is that? 16x equals 2x squared. 8x equals x squared minus 8x equals 0. X equals 0 and 8. Does that make sense? You okay with that? Now, okay, so I got these two quantities, x equals 0 and x equals 8. I have a typo because I didn't change my choices. Whoops. So, hold on. This is supposed to be 0. This is supposed to be 0, 5. This is supposed to be 0, 5, 8. This is supposed to be none of the above. That's what I get for rushing this thing out in like 5 minutes before the review session. Sorry about that. Oh, whoops. Okay. All right, everybody okay with this? All right, sorry about my little typo there. Okay, so I'm trying to determine what input values of x will produce identical values of t. Now, I propose that if I plug in x equals 0 to this expression, what do I get? 0 times 0 divided by 16 minus 0. I get 0. If I plug in 8, I get 8 times 8 divided by 16 minus 8, so 64. Exactly. I'm not going to evaluate this because if I plug in 8, 8's greater than 5, so that value isn't even going to come up right here. Does that make sense? So I propose then that the only valid solution from this is x equals 0. You see what I mean? Does that make sense? Now let's do the next one. So t equals x star 5 slash 10 minus x, or that's just 5x divided by 10 minus x. Now, I'm trying to determine what value will happen, or what value will generate an equal answer. So I'm going to set that equal to x and solve. So x 10 minus x is 5x. 10x minus x squared equals 5x. So 5x minus x squared equals 0. So that's x 5 minus x equals 0. So x equals 0 comma 5. So if I plug in x equals 0, I get 0. If I plug in x equals 5, I get 5. Okay? Is 0 a valid answer? No, that goes off the previous one. Is 5 though? Yeah. So here, the only valid answer is x equals 5. So the only two valid answers are 0 and 5, so the answer is B. Apologies for the confusion there. I just copied and pasted my answers from the last one. Whoops. Any questions?
Well, I just got just 5 though, because the x is...
Yeah, but this one works as well. Because I can plug in 0, and this expression will give me 0. See, over on the first expression, 0 and 8 were mathematically valid answers, but the program only allows 0. Over here, 0 and 5, but the program only allows 5. So the two programmatically allowed expressions are 5 and 0.
Well, what I was getting at was I didn't distribute the x. I just went ahead and divided 5x by the x. So just 10 minus x equals 5.
You mean you canceled here? Well, no. Yeah. No. I see what you're saying, but no. All right. Does anybody have any questions about this? All right. The rest of this, I think, is going to go pretty quickly. Now, this is such a simple part of the exam, but a lot of people see it and they just go, what in the heck? It's really not that bad. Now, the first set of computational questions you're going to get are going to be related to programs. Very basic programs. The language really doesn't mean much. It's all just about understanding the flow. The second are related to spreadsheets. So in a typical spreadsheet program, what is the cell directly to the right of AB4? AC4. You're exactly right. Okay. Now my solution is to this problem is very exotic. We're just going to pull up Excel and look at it. No, but
Took a second to visualize it in my head, yeah.
you're right. That's the whole point, you know. But yeah, when you look at your columns after Z, they go A, B, A, C, A, D. So if you're here at A, B, 4, which is right there, the next one to the right is a C4. So it's not hard, but you just got to think about it, you know. Okay? Now you'll like this one. How many individual spreadsheet cells are contained in that range? I'll give you all time to think about that. Yep. What you got?
80.
80. That's right. Exactly right. And the easiest way is to just look at it. So it's what, C3 to J12. So there's C3. So I know you don't have the options of using that on a spreadsheet, but here's J3, J12, right? And if I look here in the count on the bottom, 80. But yeah, you're right. As for rows, 3 to 12, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 10 rows. And then C, E, F, J, 8 columns. Make sense? Not too bad, right? All right. These are the ones I like, right here. Okay. I love problems like this. So these are not hard if you follow through, okay? And remember, what do those dollar signs mean? They lock in the cell, okay? So we have a little portion of a spreadsheet. For the spreadsheet portion shown, the formula equals B1 plus A1 times A2 is entered into this cell, okay? So what's going on is these are numbers that are just typed in. So if you want, I can pull this up and kind of show you. So if I'm looking right here, I've got, hold on, 3, 4, 5, 6, and then 111. Oh, where'd I go? Okay. All right. Now, I think I have a typo here. I apologize. On your formula, right here, where it says copied into B4, it should be copied into B3 and B4. I apologize about that. B3 and B4. I apologize about that. Sorry about that. Okay. So this formula shown is entered into B2 and copied into B3 and B4. What will be the value in cell B4? Okay? So first thing I want to do is this. Okay? Before we even open Excel and just do this problem, let's write out the formulas. Okay? Now watch this up here. Okay? If I copy this formula right here and paste it, let's say, into B3, what's it going to look like? There you go. And if I copy it down here, it's going to be equals B3 plus A1. Oh, getting ahead of myself. Times A4. Sound good? So let's take each of these one at a time. Let's start off with B2. So B2 is going to equal B1, which is 111, plus A1 times A2, so 3 times 4. So was that 111 plus 12? Was that 123? So B3 is going to equal B2, which is 123, plus A1 times A3, 3 times 5. So 123 plus 15, 138. B4, 138 plus 3 times 6. So 138 plus 18. Does that make sense? Everybody okay with that? These are not that hard. The next one I think is a little more exotic. All right. Everybody good? So. All right. Now the next one, we have the following data. Now we have a formula that is typed into C2, and this one is correct. It's copied into that cell and it's copied into that cell. What are the values in those cells going to be? Okay, so let's start off with the bottom one. Okay, now, first off, if I copy that down, it's going to be, and I'm talking about this formula right here, it's going to be what? D2 times what? If I copy this cell into here, B4, sorry, B4. Yeah. B4 times what? The row's locked. A1. So that is 6 times 10, which is 60. So even I got it mixed up. Now, what's this one going to be right here? Well, if I'm at B2, it's going to say equals C2 times what? C2 times B what? B1. See, yeah. So C2 is, well, what we just, well, we haven't computed that one, so we got to go through and do that over here. So that equals B2, which is 4 times 10, which is 40. So this is 40 times B1, which is 11, 440. Did y'all see that? Because it's referring to C2, which is here. We had to go through and compute that. What do you think? Yeah, as long as you pay attention. And the programming, it really isn't that bad, is it? As long as you just follow it down, you know? Any questions? That's all I got for you on this. The probability and statistics was something we weren't really able to cover in our last math session. We just didn't have the time. I mean, we could have sat there till 11 o'clock at night, but I don't think anybody wanted to. I don't know what you're trying to say there. I'm just somebody said something about transportation class today that I thought was pretty funny. They said that class can drive you nuts. I'm going to steal that one. All right, that's it. That's all I have for you. I think that's pretty short, but I think the whole purpose of this was to try and fill in the gaps from all the other stuff that we cover. So that's it.